Hello viewers, in today's class we are going to discuss a very interesting problem from binomial theorem, right? And here we have this problem that is we have to find the number of integral terms in the expansion of this binomial, right? So here we have 5 raised to half plus 7 raised to 1 over 8 to the power 1024, right? So here we have to find the total number of integral terms in the expansion of this binomial term, right? So to find the solution of this problem, we have to make use of the general term in binomial theorem, right? So we'll make use of the concept of binomial theorem in this problem, right? So let us consider a binomial a plus b raised to n, right? So here if we expand this binomial, then the total number of terms would be n plus 1, right? Okay, and the general term in this expansion can be given by t r plus 1, and here we have ncr, then we have a raised to n minus r and b raised to r, right? So this is the expression for finding out the general term in the expansion of a plus b raised to n, right? And here this r, it satisfies this inequality, right? Okay, so now here in the given problem, a is 5 raised to half and b is 7 raised to 1 over 8 and n is 1024, right? So if we expand this binomial, then the total number of terms would be 1024 plus 1, that is 1025, right? So 1025 would be the total number of terms in the expansion of this binomial, right? So here out of 1025, we have to find the total number of integral terms in this expansion, right? So let us first write the expression for the general term. So now the general term for this binomial expansion can be written with the help of this result, right? So we have t r plus 1 and ncr, n is 1024, and here we have r, and a is 5 raised to half, and here we have n minus r, n is 1024 minus r, and b is 7 raised to 1 over 8 raised to r, right? So this is the expression for general term. Now let us simplify it. So the binomial coefficient is 1024 CR, and here we have 1024 minus r divided by 2, right? And here we have r over 8, right? Now we can write this expression as 1024 CR 5 raised to, here we can write 1024 divided by 2. So this is 2 5s are 10, 2 1s are 2, 2 2s are 4, minus r over 2, and 7 raised to r over 8, right? So viewers, once we have obtained this expression for the general term, let us focus on these two terms, right? Now see, here we require the integral terms, right? So integral terms means we must have the integers either positive or negative, right? So for getting the integral terms, here we have the exponents of 5 as 512 minus r over 2, and the exponent of 7 is r over 8, right? So these exponents must be an integer, right? So these two exponents must be integer to get the integral terms in the expansion of this binomial, right? So let us impose a condition in R to get this term and this term as integer, right? So now for this term to be integer, R over 2 must be an integer, right? And for this term to be an integer, R over 8 must be an integer, right? So it means that R over 2 to be an integer, this R must be divided by 2, right? And similarly here, for R over 8 to be an integer, this R must be a multiple of 8, right? So if we combine these two terms, then we can see that if R is a multiple of 8, right? If R is a multiple of 8, then R over 2 and R over 8 is an integer, right? So this is the condition which we have to impose on R to get integral terms in this binomial expansion. So viewers, our R should be a multiple of 8, right? Where k is some positive integer, right? Okay, so now R can take the values. If k is 0, then we have 8 times 0 is 0. When k is 1, we have 8 ones are 8. And when k is 2, we have 16, and up to 1024, right? So here when k is 0, then we have R is 0. When k is 1, R is 8. When k is 2, then R is 16, and up to when k is 512, then the value of R is 1024, right? So whenever R is a multiple of k, then R over 2 and R over 8 are an integer, right? So viewers, here we see that this sequence of numbers forms an AP, right? So this sequence of numbers forms an AP, arithmetic progression. So the first term is 0, and the common difference is second term minus first term. So 8 minus 0, that is 8. And the nth term is an, that is 1024, right? And now here we'll apply the formula for the nth term of an arithmetic progression, right? So an is a plus n minus 1 d, right? So an is 1024, a is 0, and here we have n minus 1 times d, right? And d is 8, right? So where n is the total number of terms in this arithmetic progression, right? So this n is different from this n. So now solving this equation, we have 1024. This is 8 times n minus 1. So 1024 divided by 8 is equal to n minus 1. So we have 1024 divided by 8, that is 128. That is equal to n minus 1. So n is 128 plus 1, that is 129. Right? So the total values of R, which makes R over 2 and R over 8 an integer, is 129, right? So there are total 129 values of R, which gives us the total number of integral terms in this binomial expansion, right? So 129 is the total number of integral terms existing in this binomial expansion.